without further ado, I'm excited to get started with this third webinar in the Discovery Space Fall Webinar Series. So like usual, I'm your host, Michael Gregory from the European Physical Society. And unlike the other weeks, I'm not being joined by one of our partners who's going to be presenting, but I'll be presenting this whole session. So you'll be stuck with me, or you'll have the pleasure of being with me for the whole session. I mean, I've been around the other sessions, but I'll be the one running the show here. And I'm just realizing that I still have someone somehow stuck in the waiting room. Uh, okay, got that fixed. Okay, so. Today will be on my one of my favorite scenarios, Zookeepers of the Galaxy. I'll explain a bit about the name, where that comes from, and whatnot. But just before getting started with that, I want everyone to quickly say hi in the chat if you haven't yet done so. And please let us know where you're joining from, because it's always exciting to see all of the different places that people end up joining us from. So take a moment just to do that. As you're doing that, I'm going to pull up my screen share, start sharing my screen with a couple of slides. I'll also be showing you guys the platform. You should be used to the platform already if you've been to our previous sessions. Um, Here we go. And can someone either confirm or deny that you should be able to see my screen? I'm confident because I've got two devices. I can see my screen. Okay. Um, okay. So. Um, we're getting people saying hi in the chat. So this is the third webinar in our fall webinar series. Hopefully some of you joined last week when we heard from Dimitris about the AI enhanced pendulum scenario. The first week was an introduction to the platform. And these first couple of weeks, the September part of this series is an introduction to Discovery Space. So the theory behind it with the differentiated classroom, trying to automatically guide students through tailored learning experiences, including two example learning scenarios. In October, the shift will be going deeper into looking at how the scenarios were constructed, how to create or modify your own scenarios. So that's kind of where we're going with this. And at the end of the session, I'll speak a little bit more about the coming weeks. We're going to have a 1 week break between this session and the next one to also help mark the change between like the introduction part and going deeper, but also so that we have the schedule more well developed and we communicate not just the next session, but the next several sessions. If you've been here for the previous ones, you'll probably know already because we've mentioned it briefly in the other sessions. Louisa will be presenting the next session, which will focus on a scenario from Nucleo, the Portuguese partner where Louisa is with, but also looking a little bit deeper on the journey to where that scenario came from. So that's kind of where we are and where we're going. Um, Now I'd like to ask, can everyone in the chat say whether or not you were present either last week or the previous week? Have you been to one of these webinars this month, or is this your first time here? So please take a moment to let us know so I have an idea who I'm speaking to, if I need to go over the really basic stuff, or if I can assume that you've followed one or the other of the webinars. So please, in the chat, let me know if you've attended last week or the previous week's webinar with Dimitris, Nikos, and Evangelia, or if you're brand new. And if you don't want to write much, you can just say new, or say which one you've gone. But I'm going to take a moment so that hopefully we get a couple responses from that, so I know how to pitch this one. The The silence is getting unbearable. I'll just continue. Okay, so at least one of you has. Thank you, Zoe. At least one of you has attended one of them, and seeing a number of the names, it looks like most of the people had at least signed up for the previous ones. We don't take attendance in any kind of careful way, so it's hard to tell. Oh, last year's, and yeah, Murray, I remember you from those. So okay, so that really helps. So then I can assume people are somewhat familiar with it. Um, oh, perfect. Things were slow, probably just because of a delay on it. Because my yeah, for some reason my Zoom is working slow today. Okay, so that's great to hear that there like I thought there are a number of familiar faces, and that's kind of the level I'll pitch. Although if you have any questions, if I'm going too fast, let me know. And let me know as the slide indicates too if you have any questions so far, because that's one of the goals of having a regular series of webinars so that you can get to know us, so that you can ask if there's something you tried out from last week, if you had any issues. Um, Now's a good time to ask, but if you think of it later, if you prefer asking at the end, even if it's about a previous webinar, don't be shy. I'm a teacher. Well, my background is 15 years of classroom teaching. Now I work in the physical society doing things like this. But from my experience as a teacher, I'm used to being interrupted all the time. So please don't be shy. Uh, Oh, that's great to hear. Thank you, Stefanaki, that you were inspired by the others. Hopefully, this one lives up to that too. We'll see. So some of you may or may not be familiar, but last year I ran a similar webinar series. Only we didn't go into detail about Discovery Space itself. Our platform was a little slow getting to the point that we were comfortable sharing it with a lot of teachers via webinar because it's so there are a couple more challenges than doing things in person. And so while waiting for the platform to be more ready, I ran a webinar on artificial intelligence and machine learning for teachers that I co-ran with Kalina, who's a good friend of mine who's also a particle physicist specialized in readable machine learning. And what I mean, or what we mean by the term readable machine learning, that's machine learning that can tell you what it does. For example, if you use ChatGTP, and like most people have some familiarity with writing in prompts, having it give you an answer, if you ask it after that to explain its thinking, to explain how it got its answer, most artificial intelligence models aren't programmed to explain what they did. They 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 do what they do, but their output by default doesn't include explaining what they did. And so, in the case of particle physics experiments, it can be really useful to know what your algorithm was doing with your data. But by default, and earlier versions of AI didn't have that figured in. So AI that explains itself was kind of the specialty of Kalina, who was my partner on that one. And that led to us going a little reasonably deep for an introductory course in how some aspects of artificial intelligence works. And in this case, what's going to be relevant for Zookeepers of the Galaxy and what we'll be using today, it was image recognition. So I'm going to go into a little bit of theory before we get into the learning scenario on how image recognition works. There is a fair bit of variation in different models, but the bottom line for what an image analyzer will do, it'll take an image, like here we have a dog image, here we have a cat image, and it will split it into a number of different layers. It could be 10 layers, 28 layers, 33, a number that's usually somewhere in the tens, but depending on the model, might be more, might be less. And the different layers are isolating different aspects of the image. For example, this filter 26 in a model that we'd used is looking at edge effects. So when there's different edges on it, like the dog's color, that's an edge where we go from black to blue. The edge comes up a lot in the filter. Same with the ears. That's an edge that comes up very prominent. The back or the ears and the whiskers of the cat. And you can see how an edge filter is one of the easiest ones for humans to look at what a filter is doing and to make sense of it. Other ones could be different patterns, different types of color, um, and any kind of aspect of it. So it's like a simplified version of the image. And to read out what you do when trying to use a machine learning model, you'd have something called a saliency map. And that's looking at points that the image itself has in common with the model that was constructed of what that should be. So in this case, this is a simple image classifier classifying dog images and cat images. And it was trained, this was one we had trained on, I think it was 10,000 stock images. I could be mistaken, it might only be 1,000, but it was like a relatively large number from a free online library of dog and cat images. And we can see if we look at like the cat one, the cat's eyes, these are points that the model used. It said those eyes are distinctly cat-like. I think it's a cat because of this part that I'm showing these dots. Because of this part in the ears, the cat ears are fairly typical. I don't know if it comes up on the screen. The whiskers on this side are, and then there's other like noise. And it's saying, oh, well, that kind of fits with the model. But as a human looking at it, of course, that it's neither dog nor cat. That's part of the floor. Similar, the dog, we can see things like the dog's collar. A dog's collar is more typical for a cat, so that identified it as a dog. And there's this fake identified. You can see here, this it thinks it identified a tail. If we look as a human at the image, we can see that's not a tail. It's just a person's shirt behind the dog. But dogs would more typically have a tail that goes up like that. So that's a phantom or false identification, which in this case reinforced a correct identification, but it was just by luck in that case. Um, One of the reasons I'm explaining kind of what happens behind the scenes, and this is beyond what the scenario goes into, but it's useful sometimes to know a little bit more than we're trying to teach students, to know what's going on behind the scenes. Uh, and as part of that, we also had some fun with a couple of images. I'm going to skip to the doodles because those are the most interesting. And when we had a model that we trained on dog images and cat images, we gave it doodles, which obviously this does not look like a real dog. But if we look at the saliency map, the nose on that dog was typically dog-like. And something about the legs, I had found 86% confidence that well, 86% match that it was a dog. And we can look at the same thing for cat. And same thing if we look over, I don't know why my sound is going funny. Hopefully that's fine. If my sound goes funny again, let me know. But if we look at the saliency map, we see things like the claws and the ears, especially the other ear on the other side of the face there. Um, and it says those are typical um, claws and ears, and it thinks that's a cat. Um, So it's fairly easy to demonstrate what a machine learning model is, and that's going to be the essence of the scenario today. So I had a whole bunch of extra slides in case it was fun to look at dog and cat pictures. If we have time at the end, we can get back to them. Like that's why they're there. They're in case, but I'm not going to take the time to look at all of them. Oh, all of them now. What I'm going to do is I'm going to invite or ask you guys to go on the Discovery Space platform. So like we saw earlier, most of you have been to previous webinars, even some of you in the previous webinar series, and I know Maria had used the platform with a number of students. So hopefully, well, and a number of other people did too. Hopefully, this will be somewhat familiar with you, but if you're not familiar with it yet, if you're just joining new, you can still take the time to create an account. I'm going to copy the link to the platform and the access code into the chat, and then I'll um, take you through what to expect. Um, just need to find the chat again. Chat, chat, chat. Okay, there we go. It's finally in the chat. Okay, so now you can go into the Discovery Space platform. You get part that looks like this, and I'm going to switch which part of my screen I'm sharing. So I'm going to stop sharing for a moment just to get out of those slides and get into the platform itself. Platform, platform, platform. Okay, so yes. Um, you should be encountering a screen that looks like this. And if you already have your login and password, which a number of you do, you just click on login. If this is your first time, then you go to the create an account page. Then you enter your name, email address. We recommend you use your email address as your name, because then it's easier not to forget it. And if we end up asking you which scenarios you've created, things like that, it's easier for us to keep track as well. You choose a password and the access code, that's where you copy and paste it. It remembers it because I have a password wallet activated on my computer. That's the same one as in the chat. You copy and paste it there. The reason we have the access code is because it would usually be inconvenient to give students teacher access and have them creating scenarios, modifying scenarios. For students to use it from a student point of view, the student view is what's more adapted for that. And to do that, you as the teacher create the student accounts. Uh, if there are questions from people who either haven't seen it before, it was shown in webinar number 1. It was also shown in the spring series. But if you're new and you want that shown, let me know. I can take a moment to do that, or I could do that at the end. But I'm going to skip the part of creating student accounts because I want to get into the scenario itself. So I don't need to create the account. I just need to go back. So I need to move my Zoom control so I can. And once I'm logged in, then I see the dashboard. In the past 2 webinars, we saw a couple of things about what the dashboard shows with student statistics, gives you insight into how students are progressing through. We won't bother going into that right now because I want to go into the scenario itself. To see the scenario and to choose the different scenarios you could look at, you go into the authoring tool. Well, you could go in student view or authoring tool, but for now, I'm going to go into the authoring tool and suggest as you're following along to do so as well. And you'll see a number of different scenarios. All the ones with the green public sign will be visible for you. But in addition to the public ones, you'll see I have some that are labeled private. Those won't appear for you because they're private. They're not public ones. And we're going to use the Zookeepers of the Galaxy. It's the only Zookeepers one that's public, so the only one you'll see. But it's v2.25 because it was the version that I had made in February 2025, and then that was the live version. So even though we're several months later, and there's been some recent improvement. It's like that. That's still the version number that's stuck. Uh, and I'm gonna view it to look at it and go over the different phases of it. So it's actually fairly handy, and I'll show you. I'm using two different. Oh yeah, with my screen block thing, it doesn't come through. But I'm using two different devices, and so I can see how delayed it is my screen sharing, and it's about 10 seconds behind. I don't know why it's that slow, but If I seem to wait a bit before telling you something, it's because I'm realizing that it's taking a while to show my screen. So, like you'll see with all of the public scenarios, all of the ones that have been created by Discovery Space Partners, anyways, there's 5 phases of the inquiry cycle. Again, as Demetrius explained last time, um, there's not necessarily a standardization of terms or even of number of phases in an inquiry cycle, but the model that we're using in the context of discovery space has these 5 phases: engagement, hypothesis, experiment, analysis, and reflection. And so that guides students through different parts of the cycle. Once I scroll down, we'll see a map of that. And you can see the engagement phase is just a fairly quick activity that has one question that streams moderate and low learners to try something again. And the higher level learners skip that. In the hypothesis phase, then they're going into a little bit more detail. Same thing in the experiment phase, which is then downloading a data set and starting to train a machine learning model. It finishes with the training aspect and analyze, actually gathering results, making a results table to see how effective the machine learning model is. Um, I know from when I go to use something in class, I always test it before using it with students. So that's what I'm going to invite you to do now. So I'm going to ask you to try out the first probably, let's say, 10 to 15 minutes of it. So that'll probably get you at least through the engagement and hypothesis phase, and hopefully grabbing some data so it's ready for training. And then I'll kind of pick up and resume the rest of it from there. So what I'm going to ask you to do in the platform, go to the student view, and yes, you're in your teacher account, but you um, go to the student view part. Hopefully it'll let me go into there. And then select the Zookeepers of the Galaxy scenario to go through 10 to 15 minutes in the eyes of a student. Uh, there we go, 2.25. And that's the only one you'll see, so you don't need to worry about the different versions. They won't appear for you. 2.25 is the only one you'll see. The student view, which for some of you should already be familiar by now with Plato, the chatbot at the side. And we're going to go ahead and start that. And then Plato introduces us to the world of galaxies. So like I said, I'm going to ask you to spend 10 to 15 minutes going through this. As you do, I'm going to ask you to give me some input. And this is a strategy that is useful when doing it with students as well. I'm just going to stop sharing my screen for a moment to start sharing my slides again. And it's just for one slide, but it seems worth sharing. Okay, so back to my slides. And I'm going to ask you to use the link that I'm about to put in the chat. And every couple of minutes, it'll be about 3 times as we progress, like roughly every 5 minutes. I'm going to ask you to update me on your progress. And it's just a simple form I have where I ask you to take a screenshot of where you are in the scenario, your name, so I know who you are. And if you have any if you have any problems or feedback to share. Um, Please, as you start the scenario, that's already time number 1. I want you to go into the form, take a screenshot of where you are in the scenario, share the screenshot. If you have any problems or feedback, let me know. If not, just leave that blank and continue with the scenario. And of course, if you're having any problems getting into the platform, let me know And now is a good time for me to help you troubleshoot that as the others start on their way through the scenario. So again, please now take several minutes to start going through the first part of the scenario. And if you have any issues, I'm here to help. But otherwise, I'm going to cut off my microphone until there are questions, any need for help, so you can concentrate on starting to work your way through the scenario. Sorry, my mic was off. I said, yes, the link again. Is that the link to the platform? So there, once again, is the link to the platform, and I've included the access code below for anyone who doesn't have an account. Let me know if you need the link to the form again. Oh, the form. Okay, yeah, 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 of course. Okay, so that's the link to the form that I've just shared again now in the chat. And it's good to see the screenshots I've gotten so far. Thank you everyone who's filled in the form. Now that it's been about 5 minutes, let's have everyone take another screenshot and update me again on how you're progressing through. And again, if you're stuck on anything or if you need help or have any questions, let me know and I'm here to help. But if you're progressing through, feel free to just progress on your own. Okay. Okay, and I'm sorry for the interruption. If you're working, you can just keep working through for another 5 minutes or so. There's been a question what to do on the platform, so I've jumped on my microphone to recap a couple of the details for anyone who's is still trying to figure out how to get started. From the screenshots, it's great to see some of you have already gone through the hypothesis phase. I think I saw one or two people already on the experiment phase. I assume those are some of you, well, I'm seeing the names. There's some of you who have attended past webinars. So of course it's a bit quicker if you've done this before. So I'm just sharing my screen again with the platform. So should start coming through. Um, and once you've gotten to the platform, if you haven't yet gotten there, and again, this is only for people who haven't yet gotten to this part, we're looking for the student view, which is the fourth thing down on the menu on the left. And then in the student view, scrolling all the way down, and I'll have a couple more scenarios visible than you will, especially different versions of different ones. But when you see one with this image and Zookeepers of the Galaxy, and the only one you'll see, because the only public one, is version 2.25. So I'm going to go down to 2.25. If it turns out I missed it, I need to go back. Yeah, here we go. Zookeepers of the Galaxy 2.25. Go to start. Uh, Then when we start, we're confronted with a couple of questions. The first couple of ones are a matching activity. So Uh, oh, and this wasn't at the beginning. That sometimes happens, especially if you're using a teacher login. So I'm gonna restart the scenario. Restart and then start. Hopefully that answered that question. If there's more questions, please let me know. And because it's been nearly 5 more minutes. Let's get another screenshot. Can everyone who's making progress take another screenshot so I can check on um, uh, your progress so far? And I've got a message in a private chat from at least one of you who's for who uploading the screenshot doesn't work. If it doesn't work via the form, if you're not shy, please feel free to do it in the Zoom chat. Um, if you're shy and you don't want to share a screenshot with everyone, don't worry. It's not a big deal. The main thing is just so I get at least a couple of screenshots to know how different people are progressing. And I think the furthest I've seen so far, one of you is already downloading the data. I haven't got screenshots from everyone, so maybe some more than one of you is downloading the data. And I'd say let's take about 3 more minutes from there, and then I'll jump in at kind of where things go from there, and having a sped up summary of the end of the scenario. Okay, and it's been nearly 15 minutes you've had to work on the scenario. Those of you I've received screenshots from, you're at varying different levels, which makes sense because some people have used this before. It'll be a lot quicker than for others. But everyone I've heard from, you've at least gotten somewhere on it. You've gotten partway through. So take about another minute to wrap up what you're doing, and then I'll kind of pick up and summarize where the rest of the scenario goes from there. If you have time during this next minute or so to take one final screenshot, that's always interesting for me to see. But if you're busy finishing up what you're on, just finish up what you're on, and in a minute, I'll take over again, and I'll explain some of the key takeaways and where the scenario is going afterwards. Okay, and it's been another minute, so as promised, I'm back on doing a speed run of the last things you should have seen. So, uh, most of you had gotten through it at least the engagement and the hypothesis, where you were given pictures of different kinds of galaxies, tried to guess which ones they were. Whether or not you had background on it, often by looking at similarities, you could start picking out, like you could guess correctly, which is a way that you and then students going through the scenarios model what a machine learning model is doing, because they're not being told what a machine learning model isn't being told what to look for in the image, but they're seeing patterns that are similar and saying this one is most similar to the others. Um, and so it's interesting seeing how people in a lot of ways can learn in the same way as an algorithm. In the experiment phase, you're given the choice, well, actually, more clear on this. Given the choice of how to get the data, I forgot to warn you guys, the coding option is only for fairly advanced students who are up for a challenge and have a decent internet connection. Because part of the code, just how the code's structured to pull out images from the Zooniverse data set. The Zooniverse data set is free, it's open source, it's available for anyone who wants to use it, but it's available as a giant, like 1.2 gigabyte file with all of the images together. And it's not very easy to go through it and pick out random ones without downloading the whole set, which is why there's the option of just downloading a set. And they're into 8 different folders of 100 different pictures. The pictures are only low resolution. There's only so much resolution a satellite can take of a distant galaxy anyways. But also for machine learning, typically resolutions are quite low, between 50 and 200 pixels in each direction. So the file sizes are tiny. Like for all of the data sets, all 8 folders with 50 spiral, 50 galaxy, the total size is something like 5 megabytes. So it'll be tiny. So getting it downloaded and then training the machine learning model. And it's somewhere in here where most of you got to. Some of you see, I think at least one got further. Some didn't get quite so far. So that's where I'm going to pick up on things. So that's once there's the data and then training a machine learning model. So it tells you go to Google Teachable Machine. I have that already open in a different tab. I've uploaded 10 sample images from my folders. I'm going to train my model. Takes a couple seconds to train. And then once it trains it, it's going to turn on, by default, it's going to turn on my webcam, which often seems kind of silly. Oh, yes, I want to allow it. Usually it's had permission already. And now it's trying to say, well, now I look more like an elliptical galaxy. or a spiral galaxy, but I'm not a galaxy, so I'm going to turn off the webcam and input. Oh yeah, input from a file rather than from a webcam. And I'm going to go to the file of test images, which the previous step showed how to download test images. Um, because of how screen sharing works, I don't have the test images handy. Well, yeah, I mean, I have them handy, but you can't see them. You'll see I'll drag them in. So you haven't seen which test image, but this was one that was an elliptical galaxy. So the model worked well for that one. Let's try another elliptical galaxy. So even tested on only 10 images, it's doing a pretty good job. Now I'm going to go to some of the spiral ones. And so we can say, and the analysis part of the scenario, the analysis phase, then has students make a results table to show how often it correctly identifies with 90% or more confidence. And today it's just on fire. Normally after this few images, it's not quite this consistent. Here, even though it correctly identified it is a spiral galaxy, the confidence is rather low. So in the arbitrary way students were told to make a results table, that wouldn't have counted as a confident correct identification. Um, and then the next parts of it, so if we go back here and we go to the map of it, so we look at the analysis phase. The analysis is all about changing the number of images and getting different results. So results table, the number of images per class. We train it just with one image, and I'll do that really quickly. So I'm going to get rid of all but one of the, all but one of each of the images. Then when we go to once the model's trained, it'll train quickly because there's not much data to train on, but it's only going to compare if the test image looks exactly like the one we look at. So we'd expect it to sometimes get things right, but sometimes okay, input. I'm not an elliptical galaxy. Um, okay, here's our test images. Okay, test images. No. Okay. And we can see there's not much confidence here. And I'm going to try a different test image. That one was an elliptical, correctly identified, but very low confidence. Same thing for another elliptical. Let's try a couple of spiral galaxies. And that spiral galaxy is incorrectly identified. So it's not a very good model. And the student is guided to say how many in this case. And if I went through all 10, there I tried 4 and 3 out of 4 were correctly, no, with 90% confidence, none were identified with 90% confidence. And then saying, well, how many more images might we want to do? And then if we look again once more at the map, the reflection phase then looks at changing the number of epochs. That's how many times the training data is passed through. And then the questions of what's the minimum number of epochs for our model to consistently be correct? What's the minimum number of images? Because one of the biggest problems with artificial intelligence applications is the massive amount of processing power it uses. And so, of course, if we wanted our model to successfully identify shapes of galaxies as consistently as possible, if resources weren't an issue, we'd train it on tens of thousands, hundreds of thousands of images, and we'd have it train 1,000 epochs, 10,000 epochs, 1,000,000 epochs, 1 billion epochs. But there's only so much computing time, so much power, that we want to throw at any one problem. So then the question that students are guided to reflect on, and especially the high level ones, is comparing the results and trying to identify what the minimum requirements are to have a correct model. And so that's a basic overview of Zookeepers of the Galaxy of this scenario. Please let me know if you have any questions. I'll pause for a little bit longer for more questions, but interrupt me at any point if there's any questions about this scenario. And while you're thinking of whether or not you have questions, I'm going to mention the last two or three things I wanted to mention, which is this other scenario, which also uses machine learning, and it's to identify different kinds of cells. Well, to identify plant versus animal cells. And so, if you like the idea of taking students through a machine learning model, if you're interested in doing that with them, and if you teach biology in addition to or instead of astrophysics or like space science, then that's the perfect scenario for you. I'm just very briefly going to go into it in the authoring tool. We're not going to try it out. I'm not going to explain it in detail, but I'm just going to say like it's similar. I wrote it keeping in mind Zookeepers of the Galaxy and what like the strong points of it. It made a couple of improvements to how it works, but like the same thing starts out, which of these things belong together? And this one, like here, we have three different images of plant cells. One's an animal cell. In the chat, write which one you think is different, which one doesn't match this case. Either A, B, C, or D. Is one of these images significantly different than the others? And I know it's not showing all of them at the same time, like D and A don't appear. Come on, please, someone guess. Either A, B, or C or D. It did, like, it's okay if you're wrong. Just type one letter. A, thank you for guessing. So that's a good guess. You weren't given any other information. It could be A. The coloring is different. So depending on what we're looking for, that is different from the others. If we're looking for plant versus animal cells, well, actually, maybe I won't tell you if that is the one that's different or not. I'll leave that for you to discover when you try out the scenario. If we go to the next activity, how do I navigate to the next one? The next one is similar, but oh no, it's a second try on the same one. Oh, but it takes out one of the choices. So A could be right. D was not right. Um, I forgot that it led that way. And then, oh yeah, and then round two, which I was looking for. Which of these is not like the other? And same thing. Three of them are going to be one type of cell, one is going to be a different type, and it's looking if you can guess between the two. Uh, the scenario continues uh, and has students get images of it to train the model, they train the model. And then at the end, they compare their own identification to what their model looks like. And it turns out that this is a problem that machine learning models are kind of hard to train well. It's not as easy as galaxies. And so animal cells being so diverse will tend to confuse the model. So it's fairly easy for students to learn quicker than the model and to be able to identify better or to more quickly get to a level where they can identify plant versus animal cells better than their machine learning model. Getting back because I have two more slides I want to show. I think there's two. Yeah. Just to conclude things. Okay, so next time, which isn't next week. Remember, in the first 5 minutes of today, I said the schedule so far has been introducing things in September. October, we're going deeper. So we'll have Louisa from Nucleo looking inside the scenario, how deep space learning journeys work, um, using the example of embarking on Earth's annual journey, which guides students to learn about seasons and the reasons behind them. That'll be the week of October 5th, so not next week, but the following week. Um, the two reasons for that are to give a bit of a break. So we wrap up with the introduction session. We go to the deeper dive further on. Also, as you've probably noticed, the I haven't gotten the recordings of the previous sessions online yet. There's been a bit of a backlog of things, and it'll be really good on our end to have one more week to sort things out. So we have all the previous recordings from September online. So we have the schedule confirmed for October and not just giving you 1 week at a time. So that's why we'll be coming back 2 weeks from now. Um, yeah, I was going to say what date, but it's not confirmed, so it's best if I don't say anything. But you'll receive an email as soon as the date's set, the new schedule's out, and the email will direct you both to registration forms to sign up or to this link, which is the EPS Fall Webinar Series page where we have the schedule so far. And once the schedule is ready for the next part, it'll be down there as well. So check back regularly and check your inbox regularly. That being said, I'm going to stop sharing my screen. That was the last thing I planned on sharing with you. If there are questions people have either about the scenario I showed today or about anything you've seen in previous sessions, Discovery Space in general, the upcoming schedule, even though the short answer is you'll get more details soon. If there are any questions, please let me know. I'll wait for, I don't know, 30 seconds or a minute to see if there's anything that you think of, if you're shy to start saying. Um, so yeah, let me know if there's any questions. And it doesn't look like there are any questions up to this point. So thank you again for joining us. I really hope you join us again for the October deeper dive into this. You'll be receiving more information soon. So thank you and have a good evening, everyone.